Hello everyone. In this video, we're going to learn how to write and identify the characteristic of the tangent function. Alright, so let's take a look at the first example. A portion of the function f is shown above. The function f can be written as f of s equals a times tangent b of s plus d, where a, b, d are constant. Find the values of a, b, and d, right? Now, we look at this one, we need to find b. In order to find b, we need to find the period, right? Because this formula right here related to b, right? So, the period is the distance between two vertical asymptotes, right? So, we look at this one, this is pi over 4 and this is 3 pi over 4, right? So the period is 3 pi over 4 subtract pi over 4. So it's going to be 2 pi over 4. And if we simplify, it's going to be pi over 2, right? So from this one, we calculate b, right? So we have pi divided by absolute value of b. This one has absolute value sign. Equals pi over 2, right? So then b equals 2, right? Now, in order to find d, we look at the points right here. This is the inflection points. So because the inflection points at origin, so the vertical translation d equal to 0, right? Now, in order to solve for a, we pick a point and we plug into this equation. So we pick this point right here. It's going to be pi over 8, right? And 1 right here. So the point is pi over 8, 1. We plug into this equation right here. So we have a times tangent of b, we got this right here, 2 times s equals pi over 8 right here, plus d equal to 0, and this one equal to 1, right? So we solve for a. Alright, so a tangent of pi over 4, right, equals 1. So a times 1 equals 1, and then a equals 1, right? So finally we have a equals 1, b equals 2, d equals 0. So the equation must be f of s equals tangent of 2s, and that's it, right? You can use a calculator or decimal to check your work, right? Now let's take a look at the next two examples. Alright, example 2, the function h is defined by h of s equals 4 times tangent of 2s plus 5. What is the period of the function h? Now we're going to use this formula to find the period, right? So the period equals pi divided by absolute value of b, and it's going to be pi divided by 2. Now let's move on to example number 3. The function g is defined by g of s equals 2 tangent of s over 3 minus 1. Which of the following gives the vertical asymptotes to the graph of g, right? Now in order to find the vertical asymptote of this function, we look at the notes right here. The vertical asymptote of the function g is always occurs at theta equals pi over 2 plus kp, right? So we just equate this one and this one right here. Alright, so we have s over 3 equals pi over 2 plus k pi, right? And then we just solve for s, right? So we're going to multiply both sides by 3. So s equals 3 pi over 2 plus 3 pi k, right? So the answer is C. Now let's move on to the example number 4. A portion of the function k is shown above. Which of the following could be the expression for the function k? Alright, So in this situation, we only need to solve for D and B, right? Because we have no C and no A, right? We look at the inflection point right here. Normally, it's going to be at the origin, right? Now, it's shifted down 2 units, right? So, we need to subtract 2, right? So, we need to eliminate B and D, right? Now, we need to solve for B, right? We use the formula right here. Now, we need to solve for period first, right? Period is the distance between two vertical asymptotes, right? So, we have pi and 3 pi right here are two vertical asymptotes, right? So we have period equals 3 pi subtract pi, right? So it's going to be 2 pi, right? Now we use this formula. Period equals pi over absolute value of b, right? So then we have pi over absolute value of b equals 2 pi, right? And then we solve for b by taking pi divided by 2 pi, right? So it's going to be 1/2, right? So the answer must be A. Now let's take a look at the next example. The graph of the function f is given in the xy plane. If the function f of s equals a times tangent of b of s, where a and b are constants, which of the following is true, right? So now we need to solve for a and b, right? So in order to solve for b, we need to find the period, right? So the period is the distance between two vertical asymptotes, right? So the first one right here and the second one right here, right? So the period is 3 pi over 4 subtract pi over 4. So it could be 2 pi over 4 or pi over 2, right? So we use the period to solve for b, right? So pi over 2 equals pi over b, right? So then b equals 2, which is greater than 1, right? So we need to eliminate b and d, right? Now we need to solve for a. Now the parents of the tangent function always increasing, right? So it's gonna be something like this. Alright, but now the new function is going to be like this, which is there is a reflection, right? So a must be less than 0, right? So the answer must be C, right? Now keep that in mind. If a less than 0, there is a reflection. Now let's move on to the next example. The graph of the function h is given in the xy plane. The function h of s is tangent of b times s plus c, where b and c are constants. What are the values of b and c? Alright, so in order to solve for b, we need to solve for the period, right? The period is the distance between two vertical asymptotes, right? So the first vertical asymptote right here, the second one right here, right? So the period is actually 2 pi, right? Now we use this formula. We have 2 pi equals pi over b, and then b equals pi divided by 2 pi. So it's gonna be 1/2, right? And then we need to eliminate c and d, right? Now remember that the inflection point of the tangent function always at the origin, right? Now, since the inflection point of the tangent function right here, so there is a phase shift, right? So it's shifted to the right pi units, right? So when it's shifted to the right pi units, c is negative pi, right? So the answer must be B. Now let's move on to the next example. Alright, so in this example, we need to understand the slope of the terminal rate. Now we're going to use the Christmas tree trick. Alright, if the lines go in this way, the slope is positive. The lines go in this way, slope is negative. The lines go in this way, the slope is 0. The lines go in this way, the slope is undefined. Now in the first quadrant and the third quadrant, the slope is positive. the second quadrant and the fourth quadrant, the slope is negative, right? Alright, so look at the first one. In the xy plane, an angle theta is in standard position. The slope of the terminal rate of the angle theta is 1, right? Now the slope of the terminal rate is given by the formula tangent of theta equals y over s, right? Now since the slope of the terminal rate of the angle theta is 1, which is y must be equal s, right? And then because 1 is positive, so y and s have the same value and same sign, right? It's either pi over 4 or 5 pi over 4, right? Now we look at the answer choice here. There is no pi over 4, so only 5 pi over 4 works, so the answer must be C, right? Because negative root 2 over 2 divided by negative root 2 over 2, the answer must be 1, right? Now the next one. The slope of the terminal rate of angle theta is 0, right? So if the slope equal to 0, the line should be horizontal, right? So it's either this guy or this guy, right? Because tangent of theta equals y over s, right? So these 2 points have the same y value, which is 0, and s value opposites, right? So they all give the values 0, right? Now we look at the answer choice right here. Because if the terminal rate right here, the measure of the angle should be pi, right? If the terminal rate right here, the measure of the angle should be 0 or 2 pi, right? So we look at the answer choice right here, only the correct, right? Now, the next one, the slope of the terminal rate of the angle is 1 over root 3, right? So, tangent of theta equals y divided by s, and then it should be positive, right? So, the terminal rate should be on the first quadrant or the third quadrant, right? Now, since tangent of theta equals y over s, right? So it's either this angle or this angle, right? Because you have 1/2 divided by root 3 over 2, right? It's the same thing as 1/2 multiplied by 2 over root 3. So it's going to be 1 over root 3, which is this one right here, right? So the answer either 7 pi over 6 or pi over 6, right? So we only have one answer choice right here, correct? So the answer must be D, right? Now, the slope of the terminal rate of the angle theta is negative root 3. The terminal rate either in the second quadrant or the fourth quadrant, right? Because it's negative side right here, right? So we look at this one right here. It's either 2 pi over 3 or 5 pi over 3, right? Because tangent of theta equals y over s, which is root 3 over 2 divided by negative 1/2 is the same thing as root 3 over 2 times 2 over 1. Don't forget negative side, right? So 2 and 2 cancel out. It could be negative root 3, right? So the answer either 5 over 3 pi or 2 pi over 3, right? We only have one answer choice right here. So the answer must be C, right? Now let's move on to the last example. In the xy plane, an angle theta is in standard position with a measure of angle theta equals 3 pi over 4, right? Which of the following is true, right? Angle theta equals 3 pi over 4 is right here. So the coordinate point should be right here. Oh, there is mistake right here. It should be root 2 over 2, right? So we know that tangent of theta equals y over s, and this is the slope of the terminal rate, right? Now the terminal rate is right at 3 pi over 4, right? So we're going to use the coordinate point of this one, right? So we substitute into this equation. So we have root 2 over 2 divided by negative root 2 over 2, right? And then it turns out to be root 2 over 2 multiplied by negative 2 over root 2, right? Now we just simplify this one and this one, this one, this one, so the answer is 1, right? So look at the answer choice here, only C correct, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.